Good evening, everyone. Tonight we have a very special guest, Alan Friedman, who is the author of the website Inverted Imagination. Alan is going to present to us about Solar to the Max, a program that's based on his work of solar photography, astrophotography. I've been all over his website. He's well known. He's done TED Talks. He's done several major exhibits for art museums. I can't say enough about how the quality of his work and the inspiration that I've had looking at it personally, and I just wanted to know a little bit more about how to do the technical stuff, and I hope Alan will get into it. Alan is a graphic artist in Buffalo, New York, and he has you have your own greeting card business, if I remember correctly. Isn't that right, Alan?
That's right. Yeah.
All right. Well, and you can reach him at Alan at greatarrow.com, I believe, or greatarrow.com. So anyway, without further ado, Alan, I'll turn the meeting over to you. Stephen, if you could make sure Alan's able to share his screen, that would be great.
Yeah, let's see how it works. We'll start off there. Does that work okay? Everybody seeing my first slide?
Yes, I got it.
Good. Just a couple of things to start off. My website is Averted Imagination. You guys who do deep sky stuff probably know the term averted vision, which is how you look for dim, fuzzy stuff. When I founded a website, I think it was the late 1990s, averted vision was already taken. But averted imagination was what happened when the young kid in the club brings you over to the telescope and says, "Hey, Alan, I got 5 galaxies. Can you see them all?" And you look over at the eyepiece and you kind of maybe see one smudgy thing, but you don't see the others because he has really young eyes and you've got older eyes. So that's called averted imagination when you say back, "Yeah, I see them all. They look great. What a great scope." The other thing is I'm excited to touch my feet into Houston, which Don wore his Buffalo Bills hat tonight. But I have to tell you, I have a kid who went to Ohio State. So I haven't followed football since the Jets won the Super Bowl in 1969 very much. But then we have a kid at Ohio State, and you just have to get into football when your kid goes there. And you guys have C.J. Stroud, who I think is the best of the superb quarterbacks who were there all the time that we followed Ohio State football, which is going back to about 2009. And you're going to do great things with him. He's a really gifted, wonderful young man. So we watch Houston Texans football quite a bit. So, okay, I'm going to play this presentation and talk with you a little bit. So I know we're all kind of focused on the sun. Your agenda for your club looks a lot like what the Buffalo Astronomical Association looks like. Every day is filled with a public event somewheres, and now there's all sorts of worries in the city about what's going to happen to traffic, and they're expecting a couple of 100,000 people, which would double the size of our inner city. So we'll see where that all goes. But I spend most of my free time looking at the sun and have a lot of experience with eclipses. This is a kind of eclipse that I took in my backyard quite a few years ago. It's kind of a imaginary and kind of it's better than what the usual eclipse from my backyard looks like, which is more like this. There's a lot of stuff in my backyard. I live in an urban downtown setting. I've got power lines, cable TV lines, even some old landline telephone lines crossing the backyard. So there's all kinds of stuff to block the sun on a daily basis, and sometimes I try and make the best of it by doing the. I had a big wire in front of the sun one day, and I did a double exposure so I could bring them both into focus at the same time. But it's a challenge doing astronomy up here, as it maybe is for you as well. There's always stuff in the way of the sun. When it's not the moon, it's clouds. It's you have a beautiful close conjunction of Mars and the moon, and you have to kind of sneak a peek at it through a cloud break. That's a pretty common occasion here, and I'm hoping for good luck during the eclipse, but I think our chances of clear skies are pretty much 1 in 4, something like that. We get some of this every once in a while with sunshine out. But we also get stuff that looks like this, which was just last year. We get a lot of snow. We don't get fires. We don't get earthquakes. We don't usually get tornadoes, but we do get our share of snow, and sometimes it's beautiful. But I'll talk with you a little bit about how I got into this. I looked at, like many of you, when I give a public talk where I can canvass the audience, I ask how people got into this hobby. And I'd say it's got to be 7 out of 10 people somehow got to look at Saturn through a telescope, and it just turned them on, and they never looked back. And that's kind of what happened to me. I had a neighbor who had a big telescope who stored in the garage, and he pulled it out in the street, a la John Dobson, and climbed up on a ladder, and he had Saturn in the field of view. And I just couldn't believe it. And, when my kids were tiny, the only time that I wasn't needed was in the middle of the night, assuming that the kids were asleep. So that's when I would go out, and I got into planetary observing, because that's kind of what I can do from 20 feet from my back door. This is in my backyard. This is the Nordic Optic Telescope in, I think it's Sweden. I'm forgetting. Maybe it's Norway. But it's a 2.5 meter. And in 1990, they took this picture of Saturn, which was at the time the highest resolution picture of Saturn taken from Earth. And as anybody who follows what's going on in the amateur planetary observing community, you guys used to have a guy in Houston named Ed Grafton. I don't know if he's still around or has been a member of the club, but he was an early star of imaging Jupiter. He was really, really fantastic. Now young guys like Damian Peach are doing incredible work. And so many people are using Lucky Imaging to do better. So 15 years later, this is what I was able to do from my backyard using a telescope of 1/4 the diameter, 1/10 the diameter, which is, what is that, 1/40th of the resolution of a 2.5 meter telescope. But of course, using a streaming camera and techniques for averaging the frames together brought some really exciting possibilities. At that time, I got into observing Saturn every apparition, and I did this composite of 6 years of looking at Saturn. I think 2004 to 2009. The last image with the ring's edge on is a fabrication done from things very close, because when the rings went edge on in 2009, the sun was too close to the Saturn was too close to the sun to observe safely. So I put that together to close that series. And I got involved from there into doing some high resolution lunar imaging, which I loved a lot, but it was very hard. And I found myself being limited to a couple of fantastic nights in August that allowed me to do most of what I did with lunar imaging. That first image was using my 10-inch scope at a focal length of 7.5 meters. This is its native focal length, which is 3.75 meters. There's a picture of the scope a little bit later. But the question you got to ask yourself at some point is like, why do this? Why do all this work? This is a lunar orbiter image, probably about 15 feet squared on the surface of the moon. As much as I can, calculate the resolution of what I can do by counting the craterlets on the floor of Plato and how big they are. There's this, and Juno went to Cassini, went to Saturn, and it's does it make sense for us to image Saturn from our backyards when we have spaceships flying by there? And the sun, we've got multiple space-based observatories imaging the sun 24 hours a day, 7 days a week, every day of the year, and creating incredible images from wavelengths that we can't even use either as an amateur or even within the atmosphere of the Earth. So you got to, at some point, ask yourself why you're doing this, why you're struggling with it. And partly it's because it's thrilling. And we're all going to experience in a couple of weeks, hopefully, the thrill of something that is, for me, the most exciting thing I've ever seen in the natural world, which was the eclipse in 2017. I went to Western Kentucky. I didn't even intend to take pictures, but of course I set up a telescope and snapped a quick picture with my solar imaging scope a couple of seconds after totality ended. But we'll talk a little bit about the eclipse. But if you haven't seen one before, I'd really encourage you to have a very light expectation for taking pictures. There will be 100,000 spectacular pictures that you can share. You don't want to miss the experience, which goes by so quickly and is so compelling. And the moon, I mean, this image is one of the first images that I had published. It's a double exposure on film. I think I took it through my astrophysics traveler when I first got it, which would have been early to mid 1990s. It was the first image I had published in Sky and Telescope. And there's nothing complicated about it when you look at it, because your eye sees this with no problem at all, right? Because your brain and eyes together are able to have a tremendous dynamic range of perception at one time. You can see the sunlit part of the moon and the earthlit part of the moon at the same time and appreciate them. Try and do that with a camera. I mean, anybody who's done it, you either get no earthlit part or you get a tremendously overexposed sunlit part. And the only way to do this is with a double exposure. And it's something, this image has always made me appreciate our vision and what it does for us. I've gone back and taken this picture a couple of more times since 1994. This a few years ago outside my house with the chestnut tree in front. And then there's the craziness of the sun, which presents a different face every day, and dramatic things like that are just sometimes unbelievable. This image was from last season, and it just, seeing that prominence walking over the limb of the sun, it just struck me how amazing solar observing can be. And it's really what I've done since the early 2000s and since 2009, pretty much exclusively. So this is a battery of telescopes. Like many of you, I have a telescope problem, and I have more telescopes than I know what to do with. I've gotten rid of a few, but this is my collection of scopes from astrophysics. The long one is a 6-inch. The fat one is a 10-inch Mac Cassegrain. And then I have the 4-inch Traveler. And I'm very fortunate to have the tiniest scope they ever made, which is the F5 Stowaway. It's a fluorite triplet. It's only 14 inches long, and it's a 92 millimeter aperture, and it weighs 6 pounds. And that is my solar imaging telescope most often. Here it is with my hand showing you the size of it. It's incredibly portable. And with its hydrogen alpha filter, that Coronado Solar Max, I bought in either 2000 or 2001. It's one of the early instruments they made after they moved from the Isle of Man to Phoenix. And it happens to be a really good one in that it creates a very evenly lit disk of the sun. It's not double stacked; it's single stacked, but fortunately it continues to work well, and I haven't looked to upgrade it. The camera is my streaming camera up there at the top, and of course my car keys, so you can see how big it is. And so the little telescope with its Coronado filter attached is called Little Big Man. And it sits on top of my 10-inch Mac some days. If there's a good sunspot and I want to try and image the sunspot in high resolution, I'll give it a try through the 10-inch Mac. So I can mount them piggyback like that in my backyard. And otherwise, I'll put it on top of the tube rings and use it that way. And that is me underneath my solar observing cloth. My wife, Donna, is a costume designer. So I don't know if everybody has a solar observing cloth with silver lame on the outside, but you really should, because in Houston, I'm sure it's important to reflect the sun's energy away from you when you're underneath a black cloth. And also, everybody looks better in silver lame. So it's a good thing to have. So my setup for solar imaging is really a movable feast. I travel with it. I've been able to see some wonderful things. This is just south of Buffalo on Lake Erie. I was observing a partial solar eclipse in 2014. There's some pictures of it coming up. This is my smallest astrophysics mount, which I've replaced by one of these strainwave. I haven't replaced it. I still have it, and I love it. But I got a strainwave harmonic mount, which I may use to do the eclipse if I have to move around. And there's my laptop, which is all I need to take a picture. The camera is attached to the back of the telescope, and it's sitting on top of chair for some reason on top of a garbage pail. So it's a pretty lightweight setup. Those of you who do deep sky imaging might appreciate how much fun it is to do planetary imaging. One cable. And this is my case. It's an old Halliburton case. It carries everything I need for imaging except for the mount. So it's got my Traveler F5 stowaway, 1 1/4 diagonal, and an eyepiece that I use always for a quick visual look before I get started. The blocking filter is down there. To the left at the bottom is the Etalon, the 8 hydrogen alpha Etalon, and the adapter. I've got 1, 2, 3 cameras, a 3 times tele extender, and a 2 times power mate, and a couple of adapters, and it fits underneath an airplane seat if I need to. And it lets me go places like this was taken from Mount Wilson. It was the second of the 2 series of Venus transits that we had in 2004 and 2012. This was the 2012 event, and I was invited to go to Mount Wilson for the first ever Venus transit observed from Mount Wilson. And unfortunately, the seeing was pretty poor that day, but it was a wonderful, wonderful chance to be up on the mountain. I've been there a couple of times. And this was done down at the Winter Star Party a bunch of years ago. I was speaking, and somebody in the audience when I was speaking said that there was going to be a transit of the space station in front of the sun nearby in about 25 minutes. And so we closed up the talk, and a bunch of us got in the car, and we found where the center line was, and I miscalculated by about 500 feet, maybe 1,000 feet, and we barely caught it. As you can see, the space station is just scooting along the edge of the sun there. But that's always a fun circus to try and do. I've done it quite a few times since. This one was done during Solar Minimum a few years ago. And then again, it was actually the first day of summer, 2020, 2020 and 2022. They were both during the pandemic. And this one, same date, same place, but with the sun more active. And when you compare the two of them, this one came out quite well. You can really see the how the sun changes over a couple of years. I mean, there's absolutely nothing on the sun on the image in the left. And this was a wonderful partial eclipse that happened, I believe, in 2021, which I observed from the rooftop of my building where my greeting card company is. And I thought you might enjoy this picture and the next one. They're taken. I was set up with two instruments that day. This was just a 100 mm camera lens. This is the full frame taken on 35 mm frame, and this is the size of the sun at 100 mm compared to the Traveler or the Stowaway. I'm sorry, which is 450 mm. So that gives you an idea of, as you start to think about your eclipse agenda, what focal length you'll use. The 450 is a good if you're using a full frame camera, it's a good size. You'll get the full corona extensions of the corona, I think, at 450 to 500 mm focal length. But of course, if you're using a really high resolution camera, which a lot are these days, you can probably crop down if you want to and even go a little wider. And the image was taken using my biggest streaming camera, which is a 6 megapixel. It's capable of doing 12 frames a second. So it's a 1-inch sensor. And this is the size of the sun at the native focal length of the Stowaway, 450 mm, when I'm using the tiny sensor. And this is a black and white camera, so this image is colorized. Just so you know, it's the only image I really came away with from the eclipse. So this is stuff everybody with a telescope should have. These are white light filters, various ones. I have one to fit every telescope that I own now and that I've ever owned. I started off with a Thousand Oaks glass filter, but now I use exclusively filters made out of the Botter solar screen Mylar film. It's really excellent, inexpensive, and it allows for a very high resolution result. I think the only thing possibly better is a Herschel wedge. But a Herschel wedge brings up all kinds of complications because it takes up a lot of optical length at the back of your telescope. Because you have a prism in there and they're big and a diagonal. You have to have a lot of in focus sometimes to be able to come to focus if you want to add a little magnification. So these things are great, and they're still available. If you don't have one, Astrophysics still has the film in stock, and they also sell the Botter's dedicated filters, like the one on the left of this frame. That's the one I used for the eclipse in 2017. So here's what it's like to look through the 10-inch Astrophysics Mac Cassegrain on a day of reasonably good seeing. This is, I believe it's native focal length at 3.75 meters, 3750 millimeter focal length. And this in Buffalo is good seeing. I don't know how you guys do in Houston, but it's tough in Buffalo. We have a lot of asphalt roofs. I live in the city, so heat reflects off the asphalt roofs after about 10 o'clock in the morning. But if I can see the solar granulation like this in the raw video, it's a day of good seeing. And if it's forecast to be good on the clear sky clock and there's a nice sunspot group, I'll often take the time to set up the big 10-inch. And this is the image processed after using Lucky Imaging to stack multiple frames and align them in different points. I'll show you how it's done in a little bit. So white light images of the sun can be very dramatic when there are good sunspots, and we're in a point now where there are good sunspots. And this is available to any telescope for the cost. If you want to make your own filter, maybe $45 to buy. To buy one, I think you might be able to spend $150. You need to, of course, be safe, but it's definitely something to explore if you want to start getting into solar imaging and you haven't already. This was a big sunspot from 2014. The one before it, I took this data, and this was a second place image in the Astronomy Photographer of the Year Awards back, I think it was 2012. And this one was using data captured by my friend Randy Shivak. He was in Arizona at that time. He's now in southern Florida, and we processed this together. We worked on it together. But these images look very different depending on if you're in the center of the sun and can see the granulations, or more toward the edge, and you start to lose it as the edge of the sun drifts, or the foreshortening drifts toward the edge. This was the most recent one, a nice sunspot from last season. But the easiest way to get started is to take portraits of the full disk. I mean, here you don't need fantastic seeing. You just need something of interest to take. And I love to do these. The sun, I call it our neighborhood star. It's different every day. You all know, of course, that the sun rotates. The different latitudes rotate at different speeds. Similar to Jupiter, the center of the sun, the equatorial zone, rotates faster than the poles. But it rotates as fast as 21 days at the equator. So these things move and change from day to day. So here's a full disk view of that big sunspot. It was very impressive. There was, at that time, it was definitely, and it still is, the largest sunspot of the 21st century. And I believe it's the largest one going back to 1949. This was active region 2192. It was so good, I've memorized the name of it. And this is the one that just so happened to be on the face of the sun when the moon was on the face of the sun the same night. This is the partial eclipse I was imaging as the sun set into Lake Erie in that picture earlier on. And of course, this is the view through hydrogen alpha. So white light and through the hydrogen alpha filter, which isolates a narrow band down in the deep red end of the visible spectrum, 6.3 nanometers. It's a tiny slice, but it allows you to see all sorts of wonderful stuff. And I don't know how many of you got out this week to look, or actually it was mostly last week, to see this beautiful large sunspot from this year. This one I haven't memorized yet. Active region 3000 and something or other, 3090 maybe. But it was pretty interesting. If you look at the left, you'll see this linear line of sunspots all lined up in a row, which is kind of an unusual formation. And this is very impressive, especially to people who weren't observing back in 2014. But if you were, that sunspot was quite a bit larger. So here's just a little walk on the surface of the sun through the little big man, just to give you a sense of all of what you can see through a good hydrogen alpha filter. It's really an incredible view. And once you've been to a star party where somebody has an H alpha filter, it's kind of hard to avoid looking to buy one. And fortunately, there are a lot of options right now. I'm not sure about right now, because I'm sure all the filter makers are selling out of all their stuff. But when I was getting into this, Daystar was still run by, oh gosh, what was his name? I'm blanking on it. He passed away and sold this company was sold, or naming rights were sold. But he was sort of the only game in town, and Coronado by David Lunt was just getting started. And then, of course, David passed away and his son started his own company, and Meade bought Coronado. So a lot of options now. So this image was taken last season. I have a friend in Buffalo who is a very modest, wonderful man who collects some of the most austere solar observing equipment available in the world. He does work for the Erie County Public Library, but his hobby is solar observing, visual, not imaging at all. And he's loaned me a number of instruments, which I've had the pleasure of having do summer camp in my backyard. And last summer, he gave me a Lunt 130. And when I mounted my 90 in the front of the 130, I had use of a double stack filter for the first time. I've always felt that a double stack is not really important. Always increase the contrast through image processing. But I have to say, once I took the time to get this dialed in, it made for a very beautiful view with very dark filaments. Filaments are the prominences on the disk. They're called prominences when they're at the edge, but filaments when they're in front of the disk. It was a pleasure to use it. So here we're going back in time to 2009. It was the solar minimum before the last solar minimum, which kind of ended a couple of years ago. But in 2009, we also went through a period where there was there'd be a year and there'd be 250 days of sun without a sunspot visible. And if you're really into solar observing, that gets kind of old kind of fast. So I was taking pictures like this and fooling around with stuff. And at one point in Photoshop, I just hit a button that said invert. I didn't like the colors. I didn't like the detail. And it turned into this. And I was kind of stunned by it. It just presented a look of the sun that was different. And I wasn't sure if it was okay to do it. Is it appropriate to make the image negative? I mean, we all know when we shoot galaxies, sometimes we invert the image of the galaxy if we're hunting for a supernova, because sometimes the detail is easier seen black on white than it is white on black. And if you've ever been had the pleasure of having a CAT scan and been able to go look at the doctor work on the results with the technician, you'll see that they do all kinds of image enhancements to make sure they're not missing anything in this image of whatever they're looking at in your body. They invert it. They increase the contrast tremendously, just trying to be able to get the most out of the scientific data. And so I experimented more with this. This was an image I produced in 2010. It was done right before Halloween. I think it was October 28th. And I named it It's Not the Great Pumpkin, Charlie Brown. Shortened it to It's Not the Great Pumpkin. And I'd already had a couple of astronomy pictures of the day, and I sent this one to them. And I figured this is a no-brainer. I mean, it's just great. And of course, they chose something else, which was a really beautiful Witch Nebula picture. But somebody picked this up and put it out there. And it was my brief moment of internet stardom. I had 400,000 hits on my website that week, and it was being retweeted. It was before tweeting, but it was being shared in all kinds of diverse forums, Harley Davidson owners, martial arts forums. It was really kind of a fun ride for a very brief bit of time. I didn't get any work done for a couple of weeks while I was watching this unfold. But it really launched me into doing this inverted portrayal of the sun. So this is a picture of the sun as we might normally have prepared it at that time. It's positive, not inverted, and the prominences are sort of tinted red. It was a very traditional presentation of the sun. I've always liked the way that looked. This is how it looks in negative. And I'm just going to take you through a little time lapse of solar images, which I like to do a full disk image as often as I have the time to do it. They are very quick to shoot, and they take forever to process because I have to, I take single shots, but I have to align it probably 80 times on the various regions of the sun to be able to sharpen it so that the data is sharp all the way across. And these were all during the Solar Max. I had gotten a higher resolution camera, the 6 megapixel. That Great Pumpkin was done in a 2 megapixel camera. And this one is fun. You can see the depth of the solar features where they're near the limb. There was all sorts of wonderful activity happening in the middle 2000 teens. A tremendously long filament stretching almost the whole length of the sun in this one. I would experiment with colors because, of course, I'm using a black and white camera. And in a few minutes, I'll take you through that journey of deciding on colors. Now, here we're back at another solar minimum. This one, I'm not exactly sure of the date of this, but from 2019 to 2021, the sun was really asleep again. Very little going on the surface. Fortunately, prominences don't stop. So there were still some beautiful big prominences. But there were days where you'd go out and if the seeing was good, I had a hard time not doing this. But it does get hard to keep doing it after a while. Then, of course, you can move to a different wavelength. This is the sun in calcium K line, which is up in the ultraviolet. And this telescope was another rare scope loaned to me by my friend Dennis. I had this for, I think, 12 years. It finally got sold, and I opted not to buy it. But it's another wonderful way to image the sun in the lower area of the solar atmosphere, the chromosphere. Hydrogen alpha is further up. And then slowly the details started to reappear. The sunspots started to come back again, the filaments. And then by the time we got to last year, things were kind of cooking again. And we're headed towards Solar Max, which could be this year or next year. This was the last full disk portrait I did, and it was using the data from the double stack, so the contrast is higher than I normally use. But the sun is just really dancing with details almost any day. So a nice thing to do with a hydrogen alpha filter that's a little faster is to take pictures of the prominences and portraits of the prominences, which I've done hundreds and hundreds of them over the years. One of the fascinating parts of doing this is they all tend to look like things. If you use a little imagination, that's term for that is pareidolia, which is seeing yourself in the universe. We're commonly are doing that with clouds. You always see clouds that look like something. Well, solar prominences look like somethings sometimes too. This is always fun to hear the reaction when I can hear the audience. I always ask what this one is, and whatever anybody yells out is, I always say, is wrong, except enough people have seen this slide. I've been using it for years that now there's always somebody who knows what it looks like, which is Bigfoot. But solar prominences are really can be magnificent. And something very unusual, if you do astro imaging, everything that you take a picture of is pretty much the same size all the time. I mean, you can vary the focal length, but Jupiter is the size of Jupiter. I mean, the moon varies in size by 10% or something, but it's pretty much the same size. Its features are the same size. But solar prominence stuff can be big. I mean, it can be tremendous. You can go out one day and see a really large prominence, and it doesn't really matter if the seeing is good or not, because the details are so large, you can take a dramatic image even if the seeing is not perfect. And for my book, that's pretty good because I rarely have perfect seeing. All of these pictures have an occulting disk in front of the disk of the sun, and that helps. For one thing, it helps in that you don't have to process the data from the disk, which takes a long time, and it allows you to get the image out quickly, which if you like to submit to space weather, time is of the essence because any news site, news gets old really fast. It also makes it easier to see the details, which we'll see in the examples that I have a little bit later on. But of course, you can add the disk detail into the image too. And these are not captured at the same time. I should mention that the prominences require a much longer exposure than the disk. It is possible to shoot them at the same time, but I invariably shoot the disk and the prominences separately, optimizing the exposure time for each, and then combining the images later on, just the way I did in those two images that you just saw. This is the same prominence a day or two later. It was really a massive prominence, and just showing you a couple of possible ways of varying positive and negative, all presenting the information accurately, but differently. This was a very early image of a prominence I did. I like to look at that one. So here's what a prominence looks like while I'm capturing. This is just an iPhone video of my screen while I'm capturing. And again, the beautiful thing about any kind of planetary imagery is that you're able to watch the thing live in your laptop underneath your silver lame observing cloth, and you can focus looking at the object in real time, which is a huge advantage for getting sharp focus. And this was the image that came out of that imaging session. The seeing was relatively good. And just a couple more images where the disk has been incorporated, the disk chromospheric details have been incorporated into the image. A splatter of matter at the edge of the sun where you can always see depth in a way that you can't in the center of the sun. And this was an image captured just after an X-class flare last year. Yeah, last year? No, I think the year before, 2022. These last two images are the most recent. This one, somebody moonwalking on the edge of the sun in a very deep, cavernous, active region. And again, this image, which just, something about it just fascinates me. So just a quick look at this image and how it was made. This might give you a couple of pointers for doing this. I have a more detailed Photoshop file, which I'll show you in a couple of minutes. Should check and see how I'm doing with time here. Ooh, it's almost, well, it won't take too much longer. We're almost done. So this is an image which won the Astronomy Photographer of the Year solar section. I think it was 2019. It was right before the pandemic. And this just shows you my workflow in doing this. So remember, I said that I average the image multiple times. This is the little red squares on the left show you my selections for stacking for this image. You can imagine how many of them there are for the whole disk, but this is just to optimize the sharpness of each area of each prominence. And the reason for this is that stuff morphs and bloats. And if I used one point and aligned all of the frames that I'm going to stack on that one point, the sharpness would decrease as you got away from that point. So by doing it multiple times and then putting in the different pieces together as a mosaic, I can really optimize the sharpness across the whole frame that I'm doing. And I won't spend the time to talk with you much about the software I do this on, because for one, you can't buy it anymore. For two, it was on a Mac. And it's just something that you can't really get any longer, but I'm kind of a Mac guy. So there are lots of sources for doing this. AstroStacker is one, and Registax, of course, is another, but I do this on a Mac. So once I've gotten the image sharp, I think you can see the difference between the image on the left and the image on the right, how much easier it is to see the fainter details in the prominence if you block that bright disk of the sun. And that's why the occulting disk. And it works out really nicely. And I just want to show you a method for doing it, because a lot of people use the magic wand in Photoshop and they just click in the white. So they get this kind of eroded kind of rough edge around the edge of the sun. And I hate the way that looks. So I'd encourage you to make a nice smooth edge as if the moon was sitting there. And you notice the little blue disk there, which is the size of the Earth in comparison. I'll just show you how we create that. To do this in Photoshop, I enlarge the canvas I'm working on so it's big enough to take the marquee and scribe a circle the size of the disk of the sun, which would look something like that. And if you look on the the right, you can see the pixel diameter of that circle. Now, you know that there are 109 Earth diameters across the diameter of the sun. So if you take your pixel diameter for the sun and divide it by 109, you'll come up with the pixel diameter of the Earth in that field of view. And if you size an image of the Earth from space, or even just a circle, and put it on your image, you can do that wonderful kind of showing the scale of your image by how many Earths tall that prominence is. And sometimes, as in this image, I have the Earth and the moon, so you can see the distance from the Earth to the moon against this huge prominence, which is really big. Okay, if folks are interested, I have a brief Photoshop thing that I'd like to show you. And it won't take too long. I'm going to just exit this presentation and see if I can figure out how to. I'm going to stop my screen share and open up Photoshop. And let's go back to Zoom and share my screen again and tell me if this works. Did that work? Did I have to click something else? Oh, there it is. Yeah, I have to hit share. Okay.
Got it.
Okay. So wait a minute. Am I in the right place?
Seeing a sunspot on the canvas.
Yeah, okay. I want to be doing this. Let me try this one more time. I'm sorry. Oh, I see. I picked the wrong one. Got it. Okay.
Okay.
Now you should be able to see this. So this is another one of those. I have to close this down. There we go. This is another kind of partial disk of the sun with prominences. And I just wanted to give you a sense. This is the final image, but we're going to go back and look from the very base layer. And I'll just show you the process of creating this. So starting off, we just have, this is the exposure of the prominences. And you can see the white disk because the chromospheric detail has not been added. This is the exposure for the prominences, and the disk is a huge overexposed white area. So my second group, this is the chromospheric detail, and this is it before sharpening. This is it after sharpening. And then this is the final version, which I have reduced a little bit and moved into the placement, the proper placement where it should be. Now, this has not been inverted. So the next step I would do is to invert the tonality and have it look like this. And now the only problem left here is that the non-inverted layer is showing through. So I'm going to deselect that and get rid of that little gray line. And this is the monochromatic detail for this image. So in order to put color into it, I do a couple of things. And this is a little bit of Photoshop magic here, which you're welcome to write down. This layer does two things. It's putting color in, but it's also lightening the background. And the way that is doing it, it's a gradated field, and the layer type is screen. If I used it normally, it would block the data. You can see it's not 100%, it's 77%. So let's make it 100%. That's the gradation. But when I make the blending mode be, instead of normal, screen, it allows the prominence information to show through. And then I must have thought that that was just a little too much, so I brought it down to 77% and darkened it a little bit. And once I did that, the only thing left to do is to apply color to the chromosphere. And this is the chromospheric image colorized. And just to alter the color a little bit, I used just the sun disk shape with another color, only at 30%. And that's the final image there. One more demonstration. This is a full disk image, which has even more stuff going on in it. Here is the, just like in the other one, the base image, which is just the prominences. And then we can look at the chromosphere. This is the stack without processing. And here it is processed by mosaicing 92 regions. So imagine 92 squares across here, each of those optimized, the disk being aligned and sharpened, optimized for that area, and then that area put in as a mosaic 92 times to create the full disk of the chromosphere. And here it is inverted. So in order to be able to let the prominences show through, I have to cut that out. And now if I remove these chromospheric images, you can see that the disk is inserted into the prominences. But there's a problem here because the prominence exposure is much larger. So the disk, even though they were shot at exactly the same time with the same settings, the disk of the sun appears larger in the prominence image than it does in the chromosphere because of the exposure. It's overexposed around the edge. So in order to do that, to fix that, I resize the prominences down slightly. And there's a little bit of color in the prominences. And then there's that magical gradation, which is done the same way. And I'll do the same thing I did last time and show you what this looks like normal. And then is screen. I can't remember how I discovered this, but it's a magical, one of those magical things that you pay for in Photoshop that I think is worth it. So the only thing left to do is to colorize the inside, and then just a little more color added to it, just with a disk, only 9%. So not much happens if I don't use that, but it just adds a little more saturation, and that is the final image. Okay, I'm just going to go back. There are a couple more slides. Actually, I don't even think I have to go back to my screen. I think I can do it all from Zoom. So this is that next image. This is just a couple of fun things that I've had a chance to do over the last 20 years or so. This is a piece of data from the Big Bear Solar Observatory that I had the opportunity to process. They don't do that very often, but this was actually put out on the Solar Activity Facebook page. And I and a couple of other people took a turn at processing this. And this is what I came up with, inverting it and colorizing it. Sorry, I have to play. I've got this. There we go. And that is just colorized and inverted. This image was selected as a astronomy picture of the day, and it was wonderful because it was the first astronomy picture of the day that the Big Bear Solar Observatory, which is a state-of-the-art solar platform in California, the first APOD they'd had since 1997. And take a look at what solar imaging looked like in 1997. So I'm an artist by trade. I'm a greeting card publisher, but I really enjoy the printing of images and the mounting of exhibitions of prints. This is one I did in combination with a friend of mine who does beautiful enlarged images of snowflakes. And we determined when we came up with Fire and Ice that these are both things that you see all the time but can't really look at. And oddly enough, a snowflake is just about the same size, a big snowflake is just about the same size as the sun. If you were to hold your hand up, the sun is about the size of your pinky nail with your arm held out, as the same size as a big snowflake. And I love playing with the details of these prints. I have a show that's running now at the Birchfield Penny Art Center, which is the legacy of the wonderful watercolorist Charles Birchfield. And this show is his work and my work together. It's really nice. If you have nothing to do, you might enjoy visiting the Birchfield Penny Art Center and looking at the pieces from this show. His work is astounding. This is a little collaboration I did with a composer from Northern Ireland who maps scientific images to create sound. I'll play you just a little bit of it. I hope you could hear that. It goes on for about 45 minutes, but it's a really fun thing. And this is a jacket for a CD that was for a startup band in New York City. I get a lot of musicians who are interested in licensing work from me, and I usually try and make it available affordably. The cost of this was for the 2 tickets to their first appearance on Saturday Night Live, which I'm still waiting for, but hopefully will happen for them someday. And this was a lovely project with an artist in New York who did a series of books for the Japanese version of the North Face called Nanamica. In the Roots of Life, where it was done 7 times, each a different color. And this was the last book in the series, The Roots of Life Yellow, which focused on the sun. And the publisher of the book came to Buffalo, and we created this image together. And they used quite a few of my images in the book. And it culminated in a show in Japan, which unfortunately I didn't get to see because it happened on Thanksgiving and I just couldn't get there in time. But I did get one of the North Face jackets that was done for the show in yellow, in a size large. And I'll tell you, it does not fit any American who is of any size whatsoever. People in Japan, I think, are much smaller. A couple of pictures from the Solar Star Party at Neath. This is the legendary astro imager Thierry Legault underneath my legendary silver lame observing cloth. And this is something that we all love to do. I see you have as many outreach events as my club does. I think sharing the view through our telescope is the most fulfilling thing we get to do as amateur astronomers. I just love to do it. And the pandemic hit us all hard. I'm so excited to get back to sharing the view through my telescope with people and young people all over, because you can never tell what that kid is going to do with the inspiration that they get through the expensive instrument that you bring out into the fields. If you got nothing to do on a rainy afternoon, visit my website, Averted Imagination. This is the newer version of it. You can get there from the old place. I'd love to hear your thoughts. And that's the end.
Okay, thank you. Thank you very much, Alan. I think that was a great presentation there. I think we could probably have a little bit of time for questions here. There was a couple in the chat. I see Don asked, do you use different filters for the solar chromosphere and for prominences? You may have answered that during the presentation. I don't recall, but if you could.
Yeah, you pretty much use the same filter for prominences and the chromosphere. Interestingly, if you get excited about the idea of a double stacked filter, which many people do, especially after visiting NEAF or going to a solar star party, because the contrast is much stronger through narrowing the bandwidth down from say 0.7 to 0.5 or even 0.4. But the prominences are best seen through a wider bandwidth. So there's no question that a single stack is better for the prominences. The thing is that your brain is very good at seeing the contrast once you give it a little bit of time. If you're at a star party and you look through the eyepiece and there's a long line behind you and you look through for 15 or 20 seconds, your brain won't have enough time to see the subtle contrast in filaments and the active whirls and swirls of the chromosphere on the surface of the sun, or the chromosphere of the sun. But I promise you, if you give it 2 minutes, your brain will adapt, and all of a sudden you will see all this detail that you didn't see before. So before you add another 5-pound brick to the front of your telescope or spend the extra $5,000 for a double stacked good size scope, I would recommend starting off with a single scope, a single Etalon, and trying it. And so I use a single Etalon for all of my images, with the exception of last year when I had a loaner second scope and I experimented.
All right, thank you. And then the other question that was in the chat was from Mauricio. He said, what is the difference between imaging with the film filters and a quark?
Well, the film filter is showing you the full spectrum of white light. So with that filter, all you're doing, which is not nothing, but you're simply reducing the solar energy down by something like 100th to 100th of 1%. It's a small amount of light that's allowed to get through. And at that, in the full spectrum of the sun, you're not seeing the chromosphere, you're seeing the photosphere. And the photosphere will show you magnificent sunspots when they exist. During solar minimum, you will get tired real fast because there is nothing to see except a white circle. But everybody should have a white light filter. When you're looking through solar eclipse glasses, you're looking through Mylar white light filter. The Botter solar screen material is just a higher tech, very interesting, version of that material. Inexpensive, but it doesn't affect the wavefront of your optic much at all. A piece of glass will hurt it much more. Now, with a hydrogen alpha filter like a quark, you are narrowing down the bandwidth of what you're looking at to a tiny slice in that deep red end of the spectrum. That slice it's less than 1/10 billionth of a meter. It's really tiny, which is why those things are so expensive to make. They're very high precision instruments. And I'd also say they're like violins, which is kind of interesting. You might have remembered I said early on that my filter was a good one. It's good because it is on band across the full disk of the sun at a focal length of 450 millimeters, which is not an easy thing to do. You'll see a lot of images of the sun where there are kind of hot spots. They're not evenly lit. It's very difficult to dial that out. And I don't know what to say about that other than if you have a chance to look through the filter that you buy before you buy it, it can be a good thing because no two solar hydrogen alpha filters play exactly the same music. And I've had some. I borrowed a lot of them from my friend, and I have I've been disappointed with some of them. I hope that's clear.
I didn't put this question on the chat, Alan, but I noticed you were mosaicing small regions of the sun. And I just needed to clarify. It's been a while since I've used like AstroStacker or whatever. You're able to identify those small regions and stack to optimize that small region? Is that what that is?
So let me quickly run through the process that I use to do that. I think I can describe it as well as I can show it to you. So I'm using a streaming camera, right? And I'm capturing the full disk of the sun with this streaming camera. I can fit the sun at a focal length of 900 millimeters on the chip of my camera. And to do that, I use a 2x PowerMate, a 2x focal extender. So I'm working, instead of my 450 millimeter focal length, which is what my telescope is, I'm working at 900. And that gives me a circle of the sun that's pretty much almost to the edges of the chip. And I will look at the image on the screen, and I will look for a kind of steadiness in the air. It kind of comes and goes. And when I see it looking promising, I'll hit the capture button on my software. And the camera will send frames to my computer, which is tethered by it's actually a FireWire connection. If anybody remembers FireWire, it's one of the reasons I use a Mac. FireWire was a wonderful thing which PCs never got into, and Mac scuttled as well. So, but I still use it because it's a very uniform, specific protocol, unlike USB, right, which can be kind of like kind of anything, or even gig E, I think. So you need different software to run all these different cameras. My FireWire cameras I can run any of them that are FireWire on this software, no matter who made them. Fortunately, nobody makes them anymore. Anyway. So we're back to so I'm capturing these frames, and I will let it run. There's a frame counter at the bottom of the screen, and I usually let it run to about 1,800 frames. And then I stop the camera, and I'll do that a bunch of times. I'll do a different exposure for the prominences, and I will then go inside that. This all takes 10 minutes. I mean, I can be done imaging the sun in 10 minutes. And then I come inside, and I've got a couple of hours at least of work left to do. The first part of it is I use the software to evaluate these 1,800 frames. And it looks at each one of them, and it rates them by contrast, basically. That's how it decides which the sharpest one is. And at the end, I'll get a thing saying, okay, here's the histogram of your capture. Here's what the graph of it looks like. And I will tell it what percentage to pick. Usually working somewheres with around 20 to 30% of the frames. I found that to be a good ratio. So I then have the sharpest frames, and before I work on them, I look through them. I help develop this program with the software designer, because software people don't like you to be able to look at what the program is doing. But I felt it was really important for me to be able to look at these frames one at a time, at least some of them, to determine that the software has done the right job, because it's just looking at contrast, and it can make mistakes, especially if the data is noisy, like for a planetary image. Noise sometimes looks like contrast. So I will look through the first few frames and the last few to make sure I'm happy with the group. And then I will select my regions for stacking. So I've got 300 pretty good frames, ranging from best to worst. I work with the best frame, and I select the size of a square. And I can then use the cursor and click on the sun disk and place these squares all across the thing. I use pretty much a grid pattern, and I just fill it with squares. And I have to make sure there's enough contrast. I'm shown the contrast with each square. As long as my data is contrasty enough, it will successfully stack each one of those regions separately. So it's stacking the whole sun, but centered on that one region. And then the software will automatically clip out a section around that square and paste it into a master. So it will automatically make this mosaic of 85, 90, 100, and sometimes it was 170 regions when I used to work in smaller squares. And it will make this mosaic of optimized regions, each section of the sun optimized for that area. And it's much, much better than picking one area. It's a very important part of stacking, especially something large like the sun or the moon. The planets, not too difficult because you're working with a small little thing. But even in planets, though, it's nice to choose the red spot because sometimes you can get that sharper than the polar regions. But of course, I haven't done much planetary imaging in a long time, so I'll give you sun advice, but not planet advice.
Okay, I appreciate that very much. And as far as the sharpening, are you doing that all in AstroStacker, or are you doing some in Photoshop as well?
I'm doing nothing in AutoStacker because AutoStacker will not run on a Mac. I've been asked to test it like a million times, and it's like they won't make a Mac version, so I don't do it. Life is really short, and it's my point of view that life is too short to work in Windows. I have one computer that I use Windows to ship UPS, the only Windows computer allowed in my place. There is the ability to post-process in the software that I use, and it uses a routine which is very much like wavelets, if you're familiar with Registacks. What wavelets is it's basically unsharp mask, but it's doing multiple pixel radii at the same time. And it's something that you can do in Photoshop that I don't know if you can do it anywhere else, but you can sharpen an image with a sub 1 pixel radius in Photoshop. You can do it on a half pixel. And what you get doing that is a much finer result. So I do very little processing using the wavelets in the program I use. I think it's called Laplacial pyramid sharpening or something. I don't do very much of it at all. Sometimes I only work on the raw image and do it all in Photoshop. Photoshop, to my mind, is indispensable. Unfortunately, I can buy it through work, but it's a tremendously powerful program. And if you do any kind of photography, it's probably pretty important to have the Adobe.
I don't want to geek everybody out, but I'm going to ask a question. High pass filter?
No, I don't. That's an astronomy thing, right? That is used in deep sky imaging a lot to increase the.
It does, and that's why I've used it most. Yeah, it's very, very, very useful for that.
I would encourage you to experiment, to the ends of the earth. I use very restrained image processing. And when I do an image processing kind of lecture demonstration, the beauty of Photoshop, I'm sure you have this in other, so in PixInsight and stuff like that too, is the undo command, the ability to go back and of course do things in layers too. Because when you're working in a dark room, with just the light of your computer screen as you play with an image for 5 hours, after everybody's gone to bed, it's so easy to either under or over process stuff. And I see so many over sharpened images and over processed images. The rule of thumb is like an old advice I heard when you're on the New York City subway and somebody stops a guy and says, how do you get to the Museum of Modern Art? And the guy next to him says, oh, it's easy. Just get off at the stop before I do. And that's kind of how you have to do image processing. Get off at the stop before you think it's right, because it's almost always you just get too carried away with the ability to tease details out. And when you process that solar eclipse photo, watch that corona. It does not look like it's, done with an Etch-a-Sketch. It's a beautiful, subtle thing. So be sure you try a bunch of ways before you sharpen it, like absolutely crazy. Or do different versions.
I appreciate very much your answer. I always leave an image overnight and then go back and look at it again and then undo, and redo.
Good. Well, I hope I haven't gotten into too much techie detail. I don't usually run this long, but I can't see anybody being restless. So that's hard when you do a presentation. I should have used a timer, but it's great to talk with all of you. Thank you for inviting me to come to CJ Stroud's new hometown.
Thank you very much, Alan. Does anyone else have any other questions for Alan?
I think Debbie Moran's got her hand up. Is that right?
I think that was clapping.
Oh, it's okay.
So thank you very much once again, Alan. This is very good presentation. I think we all learned a lot about solar imaging. I've been kind of messing around with visual observing of the sun recently myself. I haven't tried the imaging yet.
Well, you guys got good sun down there in Houston, so I'm wishing us all a lot of luck in a couple of weeks.
For sure, yeah. Definitely. So just before we leave, I just wanted to throw this up here. Our next month's meetings, we have the novice meeting on April 4th. It's a Thursday, April 4th, and our next general meeting is on Friday, April the 5th. Visit us at astronomyhouston.org for registration details. And you can also visit us on all the socials. We're on Facebook, X, Instagram, YouTube, and or you can send us an email at info@astronomyhouston.com for more information.
Hey, Stephen, the next meeting will be March 7th, novice meeting.
Right, yeah, and so thank you, Bill. Yeah, and that was mentioned earlier before the presentation. But right. This slide does show the next month's meetings. But right, this month's novice meeting has not happened yet. That is going to be this coming Thursday at 7 p.m. March 7th. Don't miss Bill's talk. I'm sure Bill will be as interesting as always. So thank you, everybody. We'll see you all next month.
Good night.
Good night.